Welcome to this explainer. Look, we all love our sleek, perfectly silent electronics and our ultra-efficient smart home devices. But today, we're looking past that shiny, sterile exterior and diving deep into the messy, toxic reality of how they're actually manufactured. Creating these technological marvels requires an incredibly complex and sometimes hazardous industrial process. So we're going to unpack the Sustainability Accounting Standards Board, or SASB guidelines, for the electrical and electronic equipment industry. Specifically, we'll focus on how these massive tech giants are required to track, manage, and report the hazardous waste they leave behind. Let's just dive right in with a fundamental question. What is the unseen toxic footprint of the devices you use every single day? It's really easy to just imagine our electronics being assembled in these pristine, dust-free, perfectly controlled lab environments. And while that's partly true, there is a stark contrast between those highly controlled labs where chemical technicians are carefully neutralizing wastewater treatment sludge and the chaotic, messy reality of industrial field response teams in full protective gear managing a real-world environmental cleanup. Both of those scenarios, they're very much a part of the electronics life cycle. Here is our roadmap for demystifying these industry standards. We'll start with the hazardous waste reality, move into heavy metals and sludge, then we'll look at the waste management life cycle. From there, we'll explore managing reportable spills, and finally, we'll examine the actual cost of those liabilities. Part 1. The hazardous waste reality and electronics toxic byproducts. When companies are operating at a massive global scale, building everything from power generation equipment and energy transformers to the tiny circuits in your personal devices, they are generating a massive footprint of byproducts. And under the SASB framework, they have to meticulously track all of it. That specific metric code RT-EE150A.1, it isn't just bureaucratic alphabet soup. It is a strict mandate requiring companies to quantitatively report exactly how much dangerous material is left over after our gadgets are made. And how is that volume actually measured? In metric tons. I really want to emphasize the gravity of this data. We aren't talking about a few stray pounds of chemicals tossed in a dumpster out back. The standards require reporting in metric tons of waste generated. When you try to visualize the sheer physical volume of a single metric ton of chemical waste and then multiply that by the incredible output of a global electronics manufacturer, it creates an immediate understanding of the scale we're dealing with here. This is exactly why strict accounting is absolutely vital. All right, part 2. Heavy metals and sludge, defining the threat. So let's translate this corporate reporting into the physical realities on the manufacturing floor. When we say hazardous waste in the context of electrical equipment, we are mostly talking about industrial byproducts like heavy metals and wastewater treatment sludge. But what exactly makes this waste hazardous? According to the SASB standard, it's not just some subjective label a company gets to decide on. It is grounded in strict legal frameworks governing transport, treatment, storage, and disposal. And what if an operation is located in a jurisdiction with weak local laws? Well, the standard points them straight to the strict United Nations Basel Convention. There is simply no escaping the regulatory net. If it's toxic, it must be tracked. Moving on to part 3, the waste management life cycle, treating the threat. Taking this from the problem to the solution, imagine chemical technicians in a highly controlled lab environment working to meticulously neutralize all that toxic sludge. This flowchart illustrates the strict mandate to handle it. Step 1 is waste minimization, basically reducing generation right at the source. Step 2 is recycling and reclaiming. And Step 3 is secure disposal. Now, the standard acknowledges that while these activities require a significant initial investment, they are absolutely critical. Executing this flowchart effectively reduces long-term costs and completely mitigates the massive risk of remediation liabilities down the road. Let's break down Step 2 of that flowchart, recycling. Companies are required to disclose the exact percentage of their hazardous waste that is recycled. But they can't just throw the word recycled around loosely for good PR. Under these SASB technical protocols, recycled waste specifically includes materials that are reused, reclaimed, or remanufactured. It literally has to re-enter a productive life cycle. And here is a very strict zero wiggle rule. Incineration does not equal recycling. Even if a company incinerates combustible hazardous waste to generate energy, a process known as energy recovery, it explicitly cannot be considered within the scope of recycled waste. They might disclose that practice separately, but they absolutely cannot use incineration to artificially inflate their recycling percentages. Total transparency is demanded. Which brings us to part 4, managing reportable spills when things go wrong. We are now transitioning away from the neatly controlled lab environment and theoretical flowcharts straight into the chaotic, high-stakes reality of field response teams dealing with environmental leaks. When toxic sludge actually breaches containment, what are the rules? Well, we have to zoom in tightly on the definition of a reportable spill. It isn't just a knocked-over barrel. The standard clearly defines it as any release greater than or equal to the quantity required to be reported to authorities. So that encompasses sudden leaks, emissions, accidental discharges, and even slow abandonment releases over time. This brings us to another major metric. Companies must disclose the total number of spills, but more importantly, the aggregate quantity of those spills, measured in kilograms. Every single kilogram of a marine pollutant or hazardous material released across all jurisdictions where the entity operates has to be tallied up. The liability attached to tracking and reporting this aggregate quantity is intense, for sure, but it gives investors and the public a crystal clear, unfiltered picture of a company's operational safety. Finally, Part 5. The cost of liabilities, the long-term cleanup. Let's talk about the real-world consequences of those spills, because here's one of the most fascinating accounting rules in the entire standard. The aggregate quantity reported as spilled to the environment absolutely cannot be reduced by the amounts that are subsequently recovered. Think about that. If you spilled 1,000 kilograms, you report 1,000 kilograms, even if your short-term response teams managed to scoop half of it back up that very afternoon. The initial damage is what goes on the ledger, because long-term remediation is an entirely different, incredibly grueling reality. When we say long-term remediation, we're referring to spills from past years, sometimes even from abandoned legacy operations, where the cleanup is still ongoing today. Companies actually must discuss these legacy burdens. These activities include restrictive land use controls, continuous site monitoring, ongoing site maintenance, and seemingly endless continued cleanup efforts. We're talking about multi-year, sometimes multi-decade burdens. It perfectly illustrates exactly why proactive waste minimization at the very start of our flowchart is so incredibly vital. Failing to manage waste early on leads directly to inescapable financial liabilities later. Which leaves us with this final thought. When you step back and look at the strictness of the SASB standards, the thousands of metric tons of waste being generated, and the haunting reality of those long-term remediation sites, is the electronics industry doing enough to minimize these toxic liabilities before they leak into our environment? The standards force the data out into the light, but ultimately, it's up to companies to change the reality on the ground. Thank you for joining me for this explainer. I hope it gave you a whole new perspective on the true cost of our everyday electronics. Keep questioning, keep learning, and I'll see you next time.